Hi everyone, I am Yasin, AI/ML engineering lead at BlueCloud. Today I'll show how we deliver a production-ready AI system in days, not months, using our AI/ML accelerators on Snowflake Cortex. This is based on real enterprise implementations, so I'll walk you through the approach briefly and then show a live demo. Let's start with Enterprise AI Challenge. In most enterprises, AI projects don't fail because of models, they fail because of engineering complexity. First, setup time. Teams spend months on infrastructure and architecture before building anything useful. Second, hallucination risk. Standard AI systems generate answers but do not verify them. And third, data access. Around like 80% of users cannot write SQL or scripts, so they depend on data teams. So the result is slow delivery, low trust, and limited access to data. And our goal here is to remove this friction completely. Instead of building AI systems from scratch, we use modular microservices. Everything is based on hexagonal architecture. This gives a clear separation of layers, reusable components, easy extensibility. For example, like we have Streamlit for UI and services for orchestration, domain models for standard inputs and outputs, and Cortex adapters for Snowflake integration. And this allows onboarding in a couple of days, like 1 or 2 days, much faster development, POCs in minutes. And also we support multiple models not tied to one provider, like we can use Cloud, Mistral, or Llama. I can say this is where the speed comes from. Normally building an AI system takes weeks. With Accelerators, we just have architecture which is already defined, services that are already pre-built, and minimal configuration that is needed for the rest. So we focus only on business logic. That's how we reduce the delivery time by up to 90%. These are the accelerators we have at the moment. This list is being expanded over time. Each one solves a specific problem. For example, SQL of Thought for natural language analytics. We have chain of verification for verified retrieval augmented generation. Also for RAG, we have contextual RAG, which is for a better retrieval. And supporting tools like semantic views and data quality agents, like all built on the same architecture, so they are consistent and reusable. Let's go deep dive into this accelerator called SQL of Thought. So this is the one that I'll focus on. It converts natural language into SQL using a structured pipeline. You can see the steps here in this presentation. Instead of generating an SQL once, it goes through multiple steps. It has revision, generation, validation, execution, reflection, reasoning, and response writing steps. Each step improves and validates the output. So the system is not just generating results, it's also verifying and correcting itself on the fly. So that's how it differs from traditional text to SQL, basically. So we have a sample use case here. It's a retail use case. This is a simple example, actually. Traditional dashboards answer fixed questions, but real business questions are not fixed. For example, like which caused the drop in specific region, excluding certain conditions. That type of question is difficult to predefine. So SQL of Thought enables this kind of exploratory analysis without writing SQL manually. For that specific use case, we have some ROI metrics. Basically, this accelerator in use leads to a real impact, like 99% faster time to insight, fewer stockouts, and improved query accuracy in the end. So because the system can answer questions instantly without waiting for analysts, decisions can be made even faster and even more accurate. Here we have some measurable outcomes, like across the accelerators, we see different improvements. For SQL of Thought specifically, I can say around 50% reduction in data team backlog, significant time savings for business users, and faster decision making. So instead of routing every question through data teams, user can directly access insights. So before we had manual SQL, we had delays, we had fragmented systems in short, and then now, like since we have those accelerators we can use, we have instant natural language analytics, we have self-correcting queries and reusable architecture. And this is how systems like Blue Talent, HR, talent matching project of BlueCloud were rebuilt in 1 week instead of weeks of custom development, to be honest. So let me show you the demo. I think it will be much better to understand how it actually works. So again, this is for the HR talent matching use case that I mentioned. So it's using the same data, but in a limited way because it's a demo. So here you see the Streamlit UI. In this example, I'm going to use the employee skill data as I mentioned, and the goal is to find the best candidate for a role. So instead of writing in SQL, I'll just ask in natural language. Let's say, find 3 candidates for AI solutions architect role with strong Python and Snowflake skills. So this is a very brief description. So let's see what we can find with this one. As the system processes this, let me walk you through each step. So basically there's input revisor, the question is refined, then SQL is generated using Cortex analyst with a semantic view. We validate using syntax checks and an LLM for the SQL generated. And then the query runs in Snowflake and the system checks if results make sense or retries needed. Here you can see the configuration, so it can try up to 2 times to correct it. Other than that, there's a reasoner. We generate reasoning based on the data. And finally, we have a response writer where we produce a business-friendly answer. So in the output, we'll have interpreted question, generated SQL, results, charts, optionally, reasoning, and the final answer. Basically, that means everything is transparent and traceable. So as I said, we can see the interpreted question here. This is the original one, and this is what is sent to the LLM basically. And we have the SQL here. We can copy and use it anywhere we want actually. And then we have data result here. See, I asked for the top 3, so I have 3 names here. And here's the reasoning, like how you found these candidates, how the results answer the question I asked, etc. And here's a warning actually. And this is the business-friendly, like readable result here. This is pretty much the summary of everything we discussed so far. I can see the results here. I can see the key highlights here. And there's also some follow-up questions suggested by the system. So I can just click on one of these. I can provide my feedback whether I like the answer or not. And I can clear the chat and start over. Or I can just type in any follow-up question that I want. Basically, like users don't need SQL, but we still maintain control, validation, and explainability. And this is the SQL of Thought, natural language analytics with built-in self-correction. It's pretty simple actually, but it makes a huge difference on the prod level. Well, this brings everything together. Like the accelerators are production-ready systems, as I explained, not prototypes. They focus on speed, reliability, and simplicity. So if you are building AI on Snowflake, this approach removes most of the engineering complexity and you get the best solution that you can have in a short amount of time. So thanks for your time. Happy to discuss further.